Today we're going to be talking about graphing exponentials. Just to review, the standard form of an exponential is f of x equals a times r, which is your base, raised to the x minus h plus k. And the a, the h, and the k are the same thing they have been since we started talking about the characteristics of functions. A is your vertical shrink or stretch. H is your horizontal shift left or right. K is your vertical shift up or down. In order to determine whether it's growth or decay without looking at the graph, you focus on the r, which is the base, which is what's being raised to the exponent. If it's greater than 1, then it's growth. If it's between 0 and 1, then it's decay. If a is negative, remember, that's when you have neither. It doesn't matter what r is. If a is negative, it means it's being reflected over the the x-axis, and that means it's neither growth nor decay. If the exponent x is negative, which we haven't talked about, that means it's reflected over the y-axis, but it also switches it from growth to decay or from decay to growth. For example, if you had f of x equals 3 to the negative x, let's just say negative x. Remember, when you have a negative in the exponent, that changes the base to a fraction. So this would technically be 1 over 3 to the x, which now that's going from what you would think is growth to decay. All right, so here we're just looking at equations. We're not graphing them, we're just looking and focusing on the r, and if a is negative, and then also we have to look at if x is negative. So in number 1, there's no negative, and we have r is 2, so this would be growth. In number 2, again, there's no negative in the x or in the a, so we look at the r, which is a fraction between 0 and 1, so this is decay. In number 3, we don't have a negative a, and we don't have a negative x, so we look at the r, which is 2.7, which is your base. That is bigger than 1, so that's going to be growth. In number 4, the a is not negative, so we go and we look at our exponent. Since it's a negative x, that's going to turn this into 1/4 times 2 over 5 to the positive x. And now that is decay. All right, in number 5, notice we have a negative in the front, so we don't need to look any further. This is neither. And number 6, if we rewrite this so that our x is first, we get negative x plus 3 up in the exponent. And again, because that negative x, that's going to switch my base to be a fraction, so this is going to be decay. Now, you could also graph every single one of these as long as you type it in correctly and look at your picture, but that takes a little bit of time, so it's easier to know what to look for if you don't want to graph it. All right, so here we have 3 raised to the x minus 1. So just looking at my equation, we know that it's growth. We know the asymptote is y equals negative 1, so I'm going to graph that. Oops. And then the domain, we talked about that yesterday, all reals. All right, and if we graph that in our calculator, then we get 3 raised to the x minus 1, and then really you don't need to graph it. You can just go to the table if you want, and then you could graph it after that. Just make sure. So I see 0, 0 as a point. I see 1, 2, and 2, 8. So those are 3 points. We need 3 points, if we can, on every graph. And when we graph this curve, remember it's a curve. It's not a 90-degree angle, and it needs to have arrows. So once we have the graph, we can do our range from the asymptote to positive infinity, and the y-intercept is 0, 0, And then our end behavior, as x goes to negative infinity, our graph is approaching the asymptote, which is -1. As x goes to positive infinity, our graph is approaching positive infinity. All right, the next one we're going to look at is 1/3 x, 1/3 raised to the x plus 3. So we can look at that and say, okay, well, the r is a fraction. So that means it's a regular fraction, so it's not improper. So that means it's going to be decay. And our asymptote is y equals 3. So I'm going to go ahead and graph my asymptote. All right, the domain is always all reals. And if we graph this, again, you can go to the table. I get 0, 4 as a point. I get -2, 12. All right, so that's going to go off my graph, but it's okay if we write that. -1, 6. And if I wanted to do +1, like it's 10/3, which is 3 1/3, so it's just a little bit more than 3. But as long as you get the idea of the shape, then you can graph it. I came a little too close to the asymptote there, but you get what I mean. All right, the range is going from the asymptote, which is +3 to positive infinity, and the y-intercept is 0, 4. As x goes to the left, which is negative infinity, my graph is going to positive infinity, and as x goes to the right, which is positive infinity, the graph, my curve, is approaching the asymptote, which is 3. All right? So here we have a -1/4, and then to the x power plus 4. Well, automatically, because it starts with a negative, I know that it is neither. My asymptote is 4, and when I graph my asymptote, I need to remember, hey, the rest of my graph is going to be below that because we said it was neither. So my domain is all reals. The range is going to come up from negative infinity, and it's going to stop at my asymptote. And then my y-intercept, I can get that from my calculator, is 0, 3. And then I can get some other points like -1, 0. And then I got -2, -12. And then if I wanted to go the other way, I got 1, 15/4, so that's roughly 3, a little bit more than 3. So I can just go here. I don't have to be perfect if I don't have whole numbers. And then I get this, kind of messed that up, and then down there, okay? So then my end behavior, as x goes to negative infinity, my graph is going to negative infinity. And remember, one of them will always go to the asymptote, so that's this one. As x goes to positive infinity, my graph goes to 4. All right, again, we're just review your transformations. You have it's reflected over the x-axis. You have a horizontal shift left-right, vertical shift up-down, and your shrink or stretch is the A. So when we discuss the transformations, okay, we're going to say this one is reflected over the x-axis because that's what the negative is. Reflected over x-axis. And then the only other transformation is it's shifted down 3. Remember, that 2 is the base, not the shrink or stretch, okay? The asymptote is y equals -3. It is neither because of that negative. And then the y-intercept, if I put 0 in for x, or I could graph it, but if I put 0 in for x, I get -4 as my y-intercept. And then for f of 2, I'm going to take 2 and put it in for x. All right, so I have to do this first. So that's -4 minus 3, which is going to give me -7. Again, you can also put that into the calculator and look where the x is 2, look what its y value is. Okay, this next one, we have a vertical stretch of 4. That's what the 4 in the front does. And then we have a shift left 3. All right, the asymptote is y equals 0. There is no negative, so we have to determine whether it's growth or decay. And because the base is 2, it's going to be growth. And then if we can either graph this or put in 0, put in 0 for the x, so we get 4 times 2 to the third power. Well, 2 to the third power is 8, and 4 times 8 is 32, okay? And then the same thing we could do to find f of negative 3. We could say 4 times 2 to the 0, because if I put negative 3 in for x, I get negative 3 plus 3, which is 0. And 4 times 2 to the 0, well, 2 to the 0 is 1, so that is just 4. But again, you can get that from the table as well. All right? Still working on transformations here. So 1/3 means it's a vertical shrink of 1/3, or by 1/3. Vertical shrink of 1/3. All right, there is no left, right. There's only an up, down. So then it's shifted up 2. And then the asymptote is going to be y equals 2. There is no negative, so we know it's not neither. So we're going to focus on r, which is 1/2. So that's decay. And then again, I can go to my calculator, or I can put 0 in for x. So I have 1/3 times 1/2 raised to the 0 plus 2. Well, 1/2 raised to the 0 is 1, so I get 1/3 plus 2, which ends up being 7/3. Or if you wanted to put it into your calculator, then you could get 7 divided by 3 is, 7 divided by 3 is 2.3333, so you could do 2.33. Then if we put negative 3 in, all right, I would definitely plug that into your calculator. Negative, or look in your calculator. So negative 1/2, I got that 1/3 in the front, times a raised to the negative 3 plus 2. So I'm going to plug that into my calculator. I'm going to do 1/3 parentheses 1/2, and then raise that to the negative 3, and then, I'm going to put x because I'm going to use the table. And then plus 2, and then I'm going to go to the table, and I'm going to look for negative 3 in my x column, and it gives me 14/3. Okay, I'm just going to leave it as a fraction because that's the most exact. All right, and then the last thing we're going to look at is writing an equation. Okay, again, some of y'all forgot the equation part on your test. So you could either do f of x, or you could do y equals. All right, it says write a new exponential function for f of x equals 2 to the x. So this is your parent graph. So I'm going to go ahead and I'm going to write that, 2 to the x. That has been vertically stretched by a factor of 5. So I'm going to put the 2 in parentheses, and I'm going to put my 5 out here, and a horizontal shift left by 2 units. So that means plus 2, and then I'm done. And this next one, write a new exponential function for f of x equals 2/3 x. So again, I'm going to do 2/3 raised to the x. That has been reflected over the x-axis, so that's a negative, and vertically shifted down by 3 units. You don't really need the vertically shifted down, but you could just say shifted down, and that would be a negative 3. And I know that I've left off the t for these 2 words there. And that is it.